you guys. Okay, so now we're gonna review glass and soil evidence and Enrique Camarena case study. Okay, so number one, observe the bullets penetrating a window, label the entry and the exit holes. So if you look at this two, we're gonna look at the small one here. This is a smaller crater, and this is a wider. If you look at the crater, it is wider crater. So the smaller one is the entry. And the wider one is the exit hole. Okay. Okay. So number two, what to test or run on glass if it cannot be physically pieced together. So the two of them that we at least did in class is the density lab or test, and also they do the refractive index. That's the one with the halo globe. Okay, so refractive index. Okay, number three. In most cases, it's the top layer of the soil is or are picked up during the commission of a crime, and it's usually 100 feet radius. Okay, now this is tempered glass. When tempered glass is broken, what do the broken pieces look like? For tempered glass, it looks diced. They're tiny pebbles, pebble-like fragments, and they are less dangerous. Okay, number five, identify the chemical added to make Pyrex glass. List two uses for this glass. Okay, so the chemical that is added to Pyrex is called boron oxide. Okay, and two uses, well, there's headlights of cars. That's the headlights, the ones in the front. Glass baking pans. Also, we use those in the lab, like beakers and test tubes. Test tubes. What is the bending of light waves as they change velocity when they go through a medium? This is called refraction. Okay. List and explain the three steps used to analyze soil. So first, and this was in your lab, you do side by side comparison, and you look at the color and texture. Make sure, of course, it's also the soil must be dry. Okay, soil must be dry. That's important. The second thing you do is microscopic observations, and you usually see it at low magnification. And the third thing you do is you do the density and gradient column. Again, you put soil in water, H2O, and then you let it settle, and then you measure layers. Okay, and basically we pretty much did number one and number three in your lab. Number 8, draw a diagram showing radial and concentric fractures. So I'm just going to do my best here. So I'm going to put the bullet hole, and then I'm going to put the radials because those are first. Okay, and then you have your concentric. Okay, so these are your concentric. These appear second. Okay, and the radials are like the spider webs. These are radial. And these appear first, opposite. They're always opposite of destructive force. Of destructive force. Okay, so list 3 items made of tempered glass. Okay, so 2 of them are basically the side and also the rear windows of your car. Windows of cars. So those are 2. And you also could see it on glass tabletops, I guess. Explain the process used to make laminated glass. What is the type of glass used for in our automobiles? So, okay, so 2 sheets of float glass are bonded together, and then with plastic film. So what is this type of glass used for in our automobiles? The windshields of cars. Windshields of cars. Bulletproof glass too is shatter. That means that's shatterproof glass. Use number 11. Use the soil texture triangle to determine the type of soil at 20% sand, 10% clay, 70%. So this is sand, so that's 20%, which is this line, and then 10% clay, which is this line. So I'm going to go here. So far that's where it is, and then 70% silt. So this is silt, so it would be this one. They all join here. So that means it is silt loam. Draw a test tube that shows the results when completing sedimentary rate of soil test. So it should look like 3 layers. It should look like it has a test tube, and I'm going to go ahead and put it on the side here. It should be, this should be sand. The second layer should be silt. And the third layer, that one's really fine. So that one takes a while, but you can start seeing it, but you have to be patient. So that is clay. And keep in mind that clay is very fine and smooth. This is very fine and smooth. Make sure you write that down. Okay, fine and smooth. Okay, it's the least dense, and that's why it's at the top, because it's the least dense. Okay, and the most dense is sand. What is the main ingredient in just ordinary glass? Basically, it's just sand, which is silicon dioxide. Okay, what is the name of the test tube used to identify soil texture? So the test is to identify the soil texture's density, gradient column, which is right there. That's it. So what agency did Enrique Camarena work for? The DA. What country was Enrique Camarena killed in? Is Mexico. What did the geologist notice about the soil when the body of Camarena was shown? It was not the same. Not the same. Not the same. And the color. Okay. What did investigators find on the soil samples taken from Enrique Camarena? That it came from the mountains. It came from the mountains. And not where Mexican authorities claim to have been. So they lied. Okay. Okay. So in reference to the diagram below, what is the correct sequence of impacts? Okay. So we need to see the ones that were the one that was very continuous. Like if you see like this one, like D, you see how D it terminates. You see how it terminates on those radial lines. It terminates. It terminates. That means wherever that radial line came from, that means if it terminated, that means it occurred basically after this bullet. Okay, after wherever that radial line it terminated. Okay, so that means B occurred before D. Okay, so that means I'm just gonna put it like this. This means it's in the beginning B, and then D is somewhere at the end. Okay, and then okay, so we know B continues on with. If you look at this radial line, it continues on with D, so that means D happened afterwards. B, it continues on with, and if you see how it bump, like here, the radial line goes with A, it continues. A terminates. Okay, so that means B occurred before A. And then B, if you look at B, it continues on with C. You see when it bumps into radial, C terminates, but B continues. And it continues to even E's radial line, and E terminates. So that means E happened somewhere in between here. Okay, so that means B is the first one for sure because it just continues on. Okay. Okay, so anyway, so let's look at A now. So A, if you look at A, it terminates here, but it continues on after it after C's radial. So C's radial terminates right when it gets to A's radials. Okay, so that means C occurred afterwards. So somewhere between those two. Okay, so now if we look at in between, let me see, and then D. If you look at D, let me see. Actually, let's look at C. If we look at C, basically if we compare at C and E, E continues on. Okay, it continues on, and then C always terminates with E. Okay, so that means E occurred before C. So then it was C, okay, and then the last one will be D. Okay. So it will be BAECD. Now yours is not gonna be that difficult. I think it only has like 2 or 3 on the exam. Okay. Okay. So anyways, if a piece of glass is placed in a liquid and appears to disappear. Okay, so when it disappears, so I don't know if you guys remember the Beckline lab, and I know I just and mainly it was I had put in Pyrex glass powdered glass of Pyrex, and I actually put it in baby oil, and baby oil has like a, I believe like 1.47, 1.46 refractive index, and Pyrex also has the same. They both are equal. So that's why you couldn't see it. You could only see the dust. Unfortunately, it was a little dirty. I mean, I swear I didn't see it when I smashed that thing, but the thing is that it disappeared. So that means that both refractive index are basically equal to each other. So that means it is equal. Okay, so the refractive index of the glass, okay, is equal to the liquid, the refractive index of the liquid. Okay, and that was exactly like I was trying to show you that in the lab. Okay. Okay, let's look at 21. If the backline is observed moving towards the liquid, then the refractive index is going to be less than the known refractive index of the liquid. Okay. Now, wherever that backline moves, that's when it's always, if it goes towards the liquid, then that means the liquid has a higher refractive index. Okay, if the backline moves towards the glass, and that's always going to be higher. So if backline moves wherever it's greater. Okay, just FYI, but be careful how it's worded though. Okay, so if the backline is observed moving towards the glass, the refractive index is greater than that the refractive index is greater on the glass. Okay, the glass refractive index is greater than the known refractive index of the liquid. Okay, so this is less and this is greater. Again, you just have to be careful how it's worded. Okay, let's for examples of manufactured soil. That is, I could tell you several. I mean, glass, paint, asphalt, brick fragments, cinder, and so on and so on. Okay, list examples of natural soil. So for soil, and I'm going to go ahead and also label what's inorganic and organic. So like rocks is considered inorganic. Minerals are also inorganic. And vegetation like trees, vegetation, that's organic. And then of course, animal matter, that's like us or any animal matter, that's also organic. Okay, now going back to the back line here, so a bright halo that is observed near the border of a particle immersed in a liquid of a different refractive index is known as, and of course is the back line. Okay, glass ship has a mass of 2.44. So it's the mass that goes, this is the division, so it will be 2.44 grams, and you divide it by using the water displacement of initial volume of 10, and then it increased to 12.6. So you subtract those two, and that should give you 2.6 milliliters, sorry. So it would be So in here, you will be 2.44 divided by 2.6, and you get basically 0.938 grams per milliliters. Number 27, if the laboratory can piece broken glass from a window or headlight together, then the evidence. Now, they can piece it together, it's individual characteristics. Otherwise, in other words, like if it's not, glass is considered class evidence. Which would be the most four useful ways in identifying a mineral crystal? For a mineral crystal, so one would be the refractive index. Well, this goes into details. Okay, so 2 is geometric, I guess a shape, geometric shape. And yes, that's important, location of origin. And very important, of course, is the color. Okay, in order to observe the color of the soil, okay, and that's why we couldn't do the first part of the lab yesterday because it was kind of misty that day. But I mean, if you could, I mean, that later on that day though, the sun came out and really could have done it quick. Just take 3 pictures of any soil that's, so you could see the colors. Okay, so in order to observe the color of the soil needs to be dry. Okay. When is soil considered individual evidence? Okay, so on this one, usually it's always classified as class evidence, but there is an exception to this, and I didn't put that in the notes, so I went ahead and put it in here. Okay, so this is only if there's like if the soil has an unusual substance, like such as pollen, seeds, or vegetation. Okay, so so if soil is unusual, has unusual substances, such as pollen, seeds, like their unique pollen, unique seeds, or vegetation. Okay, that's the only way soil can be considered as an individual evidence. Okay, number 31. A piece of glass is immersed in a liquid. It proceeds to float on the liquid surface. This shows that the density of the glass is less. Yes, definitely less. And that's it, you guys. I'm gonna add one of these questions to your exam. And it's gonna be one of those. So just answer that on your own. Okay, guys.